Welcome to class. With us, we want to discuss simple harmonic motion. Now, let's do some definition and then we do some calculations. First, let's talk about simple harmonic motion. So two definitions are critical when we are defining simple harmonic motion. So number one, we said a body is said to undergo simple harmonic motion if one, its acceleration is always directed towards the center of the center of the fixed point. Is directed towards the center of the fixed point. Is directed towards the center of the fixed point. That is what we say, number one. If the acceleration of that body is always directed towards the center of the fixed point. For instance, let's use a simple pendulum, for instance, like when you tie a rope and it's having a body to any straight line, maybe an iron or anything. As soon as you swing the string with the body, every of the acceleration comes back to the center. So we said if the acceleration is always directed towards the center of the fixed point. Number two is if the acceleration is directly proportional to its distance from that point. If the acceleration of the body is directly proportional to its distance from that point. So these are the two key definitions, or these are the two key factors that describes a body undergoing simple harmonic motion. Next thing for us to note is want to talk about period. Next thing we want to talk about is period. What is period here? So we said this is the total time taken for a body to undergo simple harmonic motion to complete. This is the total time taken for a body to complete a total cycle. A total cycle, period, please. This is the total time taken for a body to complete one cycle. This is the total time taken, or this is the time taken for a body to complete one cycle. So we said that period is given as big T, which is given as time taken over number of oscillation so which is given as T to give us over this. So this becomes my equation 1. This is it. Next thing we want to talk about is frequency. So what do we say frequency is? We say frequency is the ratio of the number of oscillation to the time taken. Is the ratio of the number of oscillation to the time taken. Also, please mind you can also define period in simple harmonic motion as the ratio of the time taken to the number of oscillation, as the ratio of the time taken to the number of oscillation. So you can do that like that. So let's go back to frequency. I said frequency is defined as the ratio of the number of oscillation to the time taken. So that means that this is the inverse of period. So that will give us number of oscillation, which is n that we know, all over time taken, which is T. So here we can now say that F becomes N over T as my equation 2. So these are the necessary things we need to know. Please, the unit for frequency, okay, the unit for period first is seconds. So obviously, why the unit for frequency is hertz. Hertz. So this is how it goes, or you can represent it as Hz. Hz. So there are also some other critical formula that we also need to learn. You can also check up the video on on circular motion we did. So there are some formulas there that we're going to be repeating here. So other formulas are, so this is 1 and 2. Let's take this one as 3. So we have this from there. We have omega to give us theta over this. Next year, number 4, we have from here, we know I gave you this one already, but also your R and your A are the same thing. So we can replace R with A here. So where we say this can be replaced with this one. So this is amplitude and this is radius. So it's very important there. So next, we have this to be omega to give us 2 pi F here. Next, we have period as well to give us 2 pi W here. And also, we have that angular acceleration will give us W square R. So I told you that you can replace R with A. Please don't forget, you can replace R with A. So anywhere you see R, you can put A there. So I can replace this one now by saying that this becomes W square A. So you can replace R with A. So that is it. Going further. So these are the necessary given formulas that we need to solve other questions. So with that said, let's do some calculations on this. So we have all of these to say where, so we say where W, this is my angular velocity. I've given you that angular velocity, which is rad per second here. Next, I have theta, which is the angle turned by body. The angle turned by body. So this is in rad. In rad. Next, I have A here slash R. So A is my amplitude, and R is my radius. They are both measured in meter. So F here is my frequency. I've given you that already. Frequency. And then that is giving us the unit as hertz. Then this one is giving us angular acceleration, which is giving us this. So this is angular velocity raised to the power of 1. Angular acceleration is raised to the power of 2. So here, so what else do we know? We know that our big T is our period. It's our period in seconds. Small t is our time in seconds as well. So V is our velocity, which we already know velocity. So in meter per sec. So this is how they all go. This is the things that we need to note going forward here. So when you understand all of this, it is easier to solve questions on this. Okay, so let's work with number one question here using these given formulas. The first thing we have, they said a particle moves in a circular orbit of radius this. If the speed of the particle is this, calculate its frequency in circles per second. So let's start with this first. So what are we given? We are told that it has a radius. So radius, small r, is given to be this. And it has a speed. V is our speed. Is given to be 0.88 meter per second here. So we asked to calculate its frequency. So how do we do that? Now, these are the formulas here. Now, observe, we have radius and we have speed. This is F. There is no radius, there's no speed here. This is just omega and pi here. So how then do we do that in order for us to get our given variable? Now, observe this, observe here. We are told that this is equals to omega radius. So we have radius here and we have V there. So that means if we get our omega, we can now find frequency here because we know pi to be 22/7. Obviously, we can get our frequency. So that is how this is done. It's very simple. It's very simple. So first, let's do this one. So we say recall that we already said from here, so that V is equals to WR. So check the first question we treated, which is circular motion. This is there, how to calculate angular frequency. So angular acceleration or angular speed, please. So what do we know here? We have our V already given there. My V is 0.88 here. And then what is my W? That's what I'm looking for. And I know my radius. My radius is given to be 0.02. So this is what is given here. Yeah? So next up, I'm looking for this omega. I will divide both sides by this value here, so that when this cancels this, so I'll have that my omega will now give me my omega here would give me so I'll have it to be 44 rad per second. So I've gotten my radius. I've gotten my angular velocity. So, but the question is, we shall have to calculate frequency. So what do I know? We know that that same angular velocity has a formula, note as this. So we say using this, using angular velocity to give us 2 pi this. We know this one. We are looking for this. Pi is always 22/7. So now we now say, put this one here now, where we say my angular speed or velocity has been given to be 44. Then this becomes 2 times my pi is always 22/7. Then times my f here. This is how this works. So if I do the math, I will have that here will give me 44. Do this one, I will have 44f here all over 7. That's what I'm having here. So I will put over 1 here so that will enable me to cross multiply. So doing this one, what do I know to do doing this one, please? So from this point, we know that if you cross multiply, we are going to have 1 times this value here. That will give us 44f. And then 44 times 7. That's what we are having there. So if I divide here by 44, divide here by 44, this takes care of this. My frequency that we are looking for becomes 7 hertz. This is how this is solved going forward. It's very simple. Please do well to subscribe if you are just coming across this channel. I need you to support me, and also I also need you to tell this to your friends. Tell them, let them know of this channel. If you are writing POST-UTME, or you're already in 100 level, or you're planning to write this forthcoming GC, WAEC, JAMB, and all of those things forthcoming, this is the best channel to be in. Do well to subscribe here, as we solve a lot of past questions here. That's what we do, past questions. See you in the next question. All right, welcome back to the second question under simple harmonic motion. So what do we know here? We are told that the period of an oscillation of a particle executing simple harmonics is 4 pi seconds. If if the amplitude of oscillation is this, calculate the maximum speed of the particle. This is WAEC question 2000. Like I said, we are solving past questions here. Do well to subscribe if you are just coming across this channel. Support me, and also tell this to your friends and everybody around. Do well to support me. Share this, please. Now, what do we know? Now, observe that I told you that in simple harmonics or simple harmonic motion, we always change our radius to amplitude. They are interchangeable. The two of them are interchangeable. If you are giving radius, you use R. If you are giving amplitude, you change R to A. So this is how it works. Now, what are we given there? Observe that we are given the time. Time is given there because they said it's 4 pi seconds. So this is 4 pi seconds here. Next up, what else are we given? We are told that the amplitude A is given to be what? 3.0 meters. So we have to calculate the speed. So speed is V. We have to calculate the speed. Now observe, this is my A, and then this is my T. There is no formula that carries that here. No formula carries this. So what do we do so that we can impute our values so we can get our V, the speed given to us? The first thing you have to do is to note that there are formulas that we can connect together. There are formulas we can connect together so that we can solve looking for the values of what we need. So this is what I mean. This is the obvious thing we want to use. This is the concluded part. So we want to make use of V equals to omega A. This is what we want to use. Omega A. Omega amplitude. But we only have A here. So how do we look for other things? Now, let's look at this quickly. Look at this value. Look at this value here. Do you agree that I can recall that T will give me 2 pi omega? Look at it critically. This T can be replaced with this. It's correct. Yes. So if you do that, this T is given already to be 4 pi. So I'll have 4 pi here to give me 2 pi over W. So I want to find W because I have A. I want to find W so that I can get my velocity. So what do? I'm going to cross multiply here. If I cross multiply, I will have that W, which is my omega, would give me, just interchange, bring this one here, take this one here. So this will give me 2 pi over 4 pi. That's what I'm having. So pi can take care of this pi. So this one here would give me 1 over 5. This is what I'm having. 1 over 5 rad per sec. 1 over 2, sorry. 1 over 2, please. 1 over 2 or 0.5. Any which one you like doing, you are correct. Now that I've gotten this, now I can now employ this formula because we are looking for the speed. So we'll say V becomes W amplitude. So V here, I've gotten my value here as 1 over 2 times, what is my amplitude there? Is 3. Is 3. That's what it means. So if I just multiply that by 3, I'm going to have it as 1.5 meter per second. This is how you solve these questions. They are very simple. This is how you solve them. Just know how to use one or two. If you know how to use one to connect the other thing, they are simple. You don't need to learn all of the formula. Just know that this value is very important. Also know that you can get F here, because if you check the formulas, there are times they will say F becomes omega over 2 pi. There are times they will say that pi here, if you are looking for pi here, becomes omega over 2 frequency. So all of these things, they are just using them to change things, to do change of subject formula. So that's what they are using it to do. So just master 1, 2, 3, 4, 5. Just master this. The other things are easily solved. This is how we solve questions like this. So we are solving the third question under simple harmonic motion. We are told that a body executing a simple harmonic motion. Okay, this is actually a NECO question. This is a NECO question. This is a NECO question. This is a NECO question, 2008. Number 12. It's a NECO question, 2008, number 12. It's very important you note that. So from here, what do we know to do? Solution, we are told that a body is executing a simple harmonic motion, has an angular velocity of this. So an angular velocity is the W or the omega we are talking of. So this will give us this value, rad per second. So this is it. And they said it has its maximum displacement. Of this. So whenever you hear the word maximum displacement, they're talking about amplitude. Amplitude is the maximum displacement of it. So we want to calculate its linear speed. So we want to calculate V. So note that your amplitude is measured in meter, not in centimeter. That means that I'm going to be converting this. So if I'm converting from centimeter to meter, I'll simply divide by 100. If you do that, we're going to have 0.06 meters. That's what we are having going forward. Divide that by 100. So from here, this is a straightforward question. So I'm just using this and this. That's all. So we say recall that V becomes WA. So we have this and we have amplitude. Don't forget this word here, displacement. Displacement is known as amplitude as well. So that becomes that V will give us what? 40 times 0.06. So V becomes 2.4 meter per second. This is how we solve this. This is very simple. Please, if you are coming across this channel for the first time, do well to subscribe. Please subscribe. Support me, please subscribe, and also tell this channel to everybody. Anybody who is doing engineering course, who is in 100 level, who is doing engineering course to any level, 100 level, POST-UTME students, WAEC student, GC that is forthcoming, and other exams, refer them to this channel. This is where we solve past question to its fullest. So, welcome to the next question, number 4 question. A particle in circular motion performs 30 oscillations in 6 seconds. Its angular velocities. These are very direct and simple questions. Now, observe this. First off, we are given 2 things. 2. It's either you make use of this formula or you make use of this formula. So first, let's do this first. Number of oscillation, this one, anywhere you hear 30 oscillation, that is N. So this is given as 30, and then we are giving T as 6 seconds. So what do you do going further? The question is we have to find angular velocity, which is omega. Observe that for frequency, you can use the formula for frequency and get your omega, or you can use the formula for your period to get your omega. Remember what I taught, what we said from the beginning. We said that period is given as what? T over N. Frequency is given as what? N over T. So these formulas are where we started from. This is the first formula I give to you. And then this can also be used to solve these two. Reason is because, observe, if I'm looking for omega, which is the angular velocity, if I use the formula for frequency, I will get the same thing, because we say angular velocity here is equal to 2 pi frequency. Or if I use the formula for period, which is 2 pi, this, I will get the same answer. So let's solve this one. Let's solve it in the two ways. Let's see how that goes. So the first way, which is my case one now. So my case one, I'll have this as, if I'm using this one to solve, so I want to get T first. I want to get T. So how do I get my T? We know that this will give us T over N. And then I know that here is 6 over my 30 here. So I'll know my T here. My T will therefore give us 0.2 seconds. So I've gotten this. But also, because I have this, I will now say recall. The question is, we should find angular velocity. Recall that T, if I'm using T now to solve, will give us 2 pi angular velocity. So let's interchange. Let's interchange this. If you interchange this here, we have that angular velocity now will give us 2 pi and T here. So what do we know here? This becomes 2 times 22 over 7 all over, what is my period here? I know that to be this. Mathematically, I can bring this one down to say 2 times 22 over 7 times 0.2. Yes. So here will give us 44 all over 1.4. So if you do the math, going further, we said that angular velocity here will now give us 44 divided by 1.4. That will give us 31.4 rad per second. So this is how you solve this. These are very, very simple questions. Very simple questions. So let's use the value for frequency and see what that would give to us. The value for frequency and see what that would give to us. Okay, so let's try the frequencies on. Let's see if we'll get the same answer. Obviously, we're supposed to get the same answer. Obviously, let's try that and see how it goes. Just that this is the inverse of this. So let's do that. Let's see. So from this point now, what do I know? We know that F will give us N over T. So what is my N? My N is 30. And then this is 6 here. So what do I know to do? Here will give us 5 hertz. So since I have this, we will now say recall, because we have a formula containing this. We'll say recall that omega will give us 2 pi f. So I'm looking for this one already. So all of this one is given. So what do I do here? I have this to be 22 over this times 5 here. So multiply all of that. That will give me 220 divided by this. So if you divide this by 7, obviously we are supposed to get 31.4 as our rad per sec. So this is how we solve this. So you can interchangeably use them. It is very simple to do that. This is how we solve these questions. All right, so here is number 5 question on the board. We are told that a loaded spring performs a simple harmonic motion with an amplitude of 5 centimeters. So observe that amplitude is measured in meter, not in centimeters. So how do we do that? We divide this by 100. That will give us 0.05 meter. That's our first task. They said if the maximum acceleration of the load is this. So A has been given to be what? So we want to calculate its angular velocity. Its angular velocity. That's what we want to calculate. So looking at this, look at this. what do you think we can use to calculate this? It's a straight and a direct thing. You don't need to stress yourself. This is a straight and direct thing. So here, this one is what we call the angular acceleration to give us this. Why am I using this? Because I have amplitude there. This is my amplitude. So from here, we can say that angular acceleration will give us W square A. We are not using R because R is not given. And I also told you that R and A can be interchanged. You can interchange R and A. I said that here. So from here, we can now solve this, given what we have here. So here is 20, and then angular velocity, which we don't know, is therefore giving us what is my A there? My A is 0.05 meters here. So this is what I have going forward. But also note, they said we should calculate the angular frequency of the motion. Angular frequency of the motion. Remember, I've already told you that you should know how to interchange. Look at this. This is all you need to know. Please, just know this fourth formula. It covers for everything that is needed except otherwise. But for what we are doing, this is all that we need to solve all we need here. So what do I do here now? I will divide here by 5. Divide here by 5. That's 0.05 here. 0.05. So that this takes care of this. And I have this to give me 20 divided by 0.05. So what do I know here? I have here to be 100. So my angular velocity will give us this value here, which will invariably gives us 20 rad per sec. So we are told to calculate the angular frequency. That's what we are told to calculate, the angular frequency. So how is that done here? From this point, we can just say using this one that has, look at this, because we have this and the frequency is what we are asked to look for. So we say using omega to give us 2 pi f. So I'm looking for f. That means if I divide here by 2 pi, I'm going to have that my f will give us this pi. So we already know that from what we want to calculate, we already know that f here would give us, we know this one already. So this is 20 going further. And then this becomes 2 times 22 over 7 here. So here I'm having 20 over 44, multiplying this by this. Then that will give us 7. So applying indices to be sure, these two are together. It is from here we have 44 over this. So I will separate this over 1, changing this one to become this, then 44 over 7 here. So 20 over 1 times, if you are changing divide to times, this goes up, this comes down. So here becomes 7 over 44. Doing the math, this will give us 140 divided by 44. If you do that here, we know that our value would give us, my frequency therefore will give us 3.18 hertz. So this is how these things are done going forward. It is very simple. It is very, very simple. It is simple. We solve past questions here. Do well to subscribe. Encourage me. See you in the next question class.